Hi, my name is William Morales Medina. I'm a fourth-year PhD candidate in the Microbiology and Molecular Genetics program from Rutgers University. I work in the lab of Dr. Nicole Fehrenfeld. My research interests are wastewater-based epidemiology. This is the study of microbes, specifically microbe that causes infectious disease in wastewater. Studying the presence of these microbes in wastewater give us information about outbreaks happening in communities. I also studied the role of microbes in drinking water treatment. So why do we study sewer system and wastewater? So sewer system receive waste from hospitals, and in hospital we have patients with infectious disease, and these microbes, these viruses, bacteria that are causing that infectious disease are present in the feces of the patient. So when the patient goes to the bathroom, those bacteria are gonna end up in the sewer system. The same happen when you're sick, when you have an infectious disease and you're sick and you stay at home, that infectious disease is going to be present on your feces, and they're going to end up, those microbes are going to end up in the sewer system. Sewer system also receive bacteria and microbes from runoff from the environment. So our interest is to study the fate, what's happening with these microbes in the sewer pipe. Are they growing? Are they developing? What's happening with them? And we are focused on biofilm. If you see the diagram here below, biofilms are the microbes that are growing attached to the sewer pipe. And we want to know if pathogens, the microbe that causes infectious disease, can develop in the biofilm attached to the sewer pipe. A previous study, for example, showed that a poliovirus, which is an infectious virus, very dangerous, was released into a sewer system, and scientists could detect the presence of this virus 4 days after it was released into the sewer system. And this was after 800 million liters of water passed through the sewer system. So we know that microbes can persist, can stay in the sewer system for long periods of time. So we want to know what's happening with pathogens, with bacteria that cause infectious disease in sewer system. The problem is that when we have storm, when we have a lot of rain, the sewer pipe reaches the maximum capacity of water that they can handle. So overflow of wastewater occurs, and all these pathogens, all these bacteria that causes infectious disease are released into the environment. So that's why we want to know what's happening with these microbes. Also, we care about sewers because we also want to help to protect the health of people that work on sewer system, the utility workers. And also sewers can give us information about outbreaks. And that's exactly what scientists like me are doing with the COVID-19 virus. We're analyzing and quantifying the presence of the virus that causes COVID-19 in wastewater, because the virus is present in the feces of the person that has the virus. If we collect a wastewater sample from a community, and in that community there is a lot of people that are positive for COVID-19, we're gonna get a higher signal of COVID-19 in the wastewater. What means that in that community where we collected the sample, an outbreak is most likely happening. And the other part of my research is about drinking water treatment, specifically the use of bacteria to remove contaminants from the water. Here I show you a diagram about the drinking water treatment process. We start at the river where water is pumped into the drinking water treatment facility. And the first step of drinking water treatment are responsible of removing those big solid particles from water. Then there is a step of filtration, which is the step I'm interested in. In this process, we remove the contaminants that are soluble in water, like manganese. When manganese is soluble in water, it causes discoloration of water, and it turns it like dark, like red, like in the picture. In order to remove manganese, we need to convert it from a soluble form into a solid form, and that's where bacteria can help us. There are some bacteria that, as part of their metabolism, they can do this chemical reaction. They can convert manganese from a soluble form into a solid form, and in that way, the manganese can be removed to a filtration process. Basically, what I do is that I study the microbial ecology of these bacteria that are capable of removing manganese. I study uh, how they grow, how they develop, how they behave in the filters. And yes, basically that is my research. Hope you enjoy it.